Today's lesson is solving one-step inequalities. Let's look at what our student objectives are. Today you're going to learn how to solve one-step inequalities, and it's going to involve all four operations. In other words, the problems are going to change operations each time. Let's look at an example. This inequality says p minus 7 is less than 3. But let's pause and think about what that's telling us. P represents numbers that we don't know the value of. So a number or numbers take away 7 and the result ends up less than 3. So let's look at what would cause this statement to be true. To solve an inequality, that's a one step, you're going to do exactly what you do whenever you're solving one-step equations. You're going to look at what's happening to your variable, the p. It's minus 7, and you're going to use the inverse operation of minus 7, which is to add 7. And the reason we do that is because subtracting 7 and adding 7 undo each other, so those go away, giving me my variable of p alone on the left-hand side. And then I think, well, what's 3 plus 7? That's 10. And I look at my inequality symbol, it's less than, so I keep it. So now I know what type of numbers will make this inequality true. Any number that is less than 10. Now let's plug in our answer and look at why 10 won't work. 10 minus 7 is 3. Well, 10 minus 7 is 3, that's not less than 3, so 10 won't work. Any number that's less than 10 is going to work. For example, 9. 9 minus 7 is 2, and 2 is less than 3. So our inequality example is, or answer is p is less than 10. So now let's look at how to find the graph. I typically, and it doesn't matter what order you do this in, but I typically focus on my inequality first and eliminate anything that has the wrong circle. That is a less than symbol, so anything like B that has a closed-in circle cannot work. Now I look at my solution. I'm looking for something that has an open circle on 10. We'll look at D. That doesn't work. That's an open circle on 4. So now I look at my direction. The P, the value is supposed to be the numbers less than 10. So I'm looking at A and C. They have the correct circle, both on 10, but I want my arrow showing the numbers less than 10. Well, 8 is less than 10, so C is the correct graph of this solution. P is less than 10. Let's look at our second example. This inequality says we have 18 added to k is greater than or equal to 29. So my values of k have to be a number that cause the left-hand side to be either 29 or greater than 29. So to solve this one, we're going to do the same thing. We're going to think, well, what's the opposite of adding 18? It's taking away 18. So I need to know what's 29 take away 18, and 29 take away 18 is 11. So now I know the numbers that work are all numbers greater than or equal to 11. So now let's find our solution. This does have the or equal to, so it's got to be a closed-in circle. So let's eliminate D. Okay, closed-in circle must be on 11. So let's eliminate based on that A. It's not on negative 11. And let's eliminate B. That's not 11. So now we have it down to knowing it has to be C. And let's just look at the direction of the arrow. This is the greater than symbol. So yes, it is showing the numbers greater than 11 also. So C would be our correct graph. All right, let's look at this one. This one means a number divided by 8 is greater than 9. Remember that fraction bar is always implying division. Okay, so what's our opposite of division? Well, we know to solve this, x has to be a number that is greater than whatever 9 times 8 is. Well, x has to be a number greater than 72. So now let's think, open circle. Well, I should not have drawn that. I don't like that because it makes it look like a greater than or equal to symbol. Let me do an arrow. Open symbol because that's greater than. So open symbol, eliminate D, not closed. Okay, on positive 72, we get to eliminate A and B. That's not positive 72. No way a number between 16 and 18 is 72. So it has to be C, and it's supposed to be numbers larger than 72, so therefore the arrow is going the correct direction. So the correct graph is C. And finally, our last example, this is 8 times our variable, 8 times a number, turns out to be less than 32. So now, let's think. We have multiplication. Opposite of multiplication is to divide. So I know x has to be a number less than whatever 32 divided by 8 is. Well, x then has to be a number less than 4 because 32 divided by 8 is 4. Now let's pick out our correct graph. I start with the symbol. Less than means open. So let's mark out C. Would not be a closed. Now look at my solution. I'm looking for open on 4. So let's eliminate A. That's open on negative 40. Finally, now let's see which direction the arrow should go. We're looking at numbers that are less than 4. So D would be our correct graph because the arrow is shading the numbers that are less than 4. So let's recap how you solve one-step inequalities. You use the inverse operation exactly like you would when you solve a one-step equation. In 6th grade, you're always going to keep your inequality symbol the same. Now I'm going to tell you that is one of those math rules that is only sometimes true. In 7th grade, that rule will become sometimes true. You're going to look at when you have to flip the direction of the inequality. But don't worry about that right now. I just wanted to point out that's a sometimes true rule. Okay? Anyways, then look at your solution. Figure out, should your graph have an open or closed circle? Make sure your circle is on the right number and the arrow is shading the correct direction.